In part C, we have to determine the nature of the stationary point. So for the nature of a stationary point, first we'll have to find the double derivative. So we already have dy dx as 3 upon square root of, so dy dx is 3 upon square root of 3x plus 4 minus 1. We can write this as 3 into 3x plus 4 to the power minus 1 upon 2 minus 1. Now differentiating this again, we'll get d square y upon dx square is equals to minus 1 upon 2 into 3, which is minus 3 upon 2 into 3x plus 4 to the power. So 1 upon 2 minus 1 will become minus 3 upon 2. And this will multiply by the derivative of 3x plus 4, which is 3. So the final answer for the double derivative will be 3 minus 3 into 3, which is minus 9 upon 2 into 3x plus 4 to the power minus 3 upon 2. Now substituting the x coordinate at the stationary point, which was equals to 4. So the x coordinate was 5 upon 3. Substituting minus 9 upon 2 into 3 into 5 upon 3 plus 4 to the power minus 3 upon 2. We'll get a negative answer, as the minus 9 upon 2 will, and the bracket will have a positive answer, and minus 9 upon 2 is outside the bracket, which means as this will be less than 0, the nature will be a maximum point. In part D, we have to find the exact area of the region bounded by the curve, the x-axis, and the lines x equals to 0 and x equals to 4. Now the equation of the line was given as y equals to 2 square root of 3x plus 4. So this was 2 square root of 3x plus 4 minus x. To find the area bounded by the x-axis and the lines x equals to 0 and x equals to 4, we'll first integrate this equation and put in the limits 4 and 0. So the equation was 2 into 3x plus 4 to the power 1 upon 2 minus x. Integrating this, we'll get, so when we integrate, we increase the power by 1. So 1 upon 2 plus 1 will become 3 upon 2. So this will become 3 upon 2. And we'll divide by the new power, which is 3 upon 2, and multiply it by the derivative of 3x plus 4. So this will multiply by 3 minus the derivative of x, which will be x, the integral of x, which will be x squared upon 2. So the 2 will go in the numerator and become a 4 upon, and this will become a 9 into 3x plus 4 to the power 3 upon 2 minus x squared upon 2. Now substituting the limits, which were 4 and 0. So when we substitute 4 over here, we'll get 4 upon 9 into 3 into 4 is 12. So first, using x equals to 4, we'll get 12 plus 4, which is 16 to the power 3 upon 2 minus 4 squared upon 2. So 4 squared will become 16 upon 2. And then we'll subtract the lower limit, which is 0. So substituting x equals to 0, we'll get 3 times 0, which is 0. So this will be 4 to the power 3 upon 2 minus 0 upon 2, which will be a 0. 16 to the power 3 upon 2. So this will be 4 square root of 16, 4, and 4 cube is 64. So this will be 4 into 64 upon 9 minus 16 upon 2. And this will become minus, so square root of 4 is 2 and 2 cube is 8. So that will be 8 times 4, which is 32 upon 9. Substituting these values in the calculator, the final answer for the area will be 16 holes 8 upon 9.